Hey everybody, you can see that? Metals, non-metals, metalloids lab. Here we go, background. You can tell me what you know about a metal, non-metal, and metalloids. Where are they found? What are their properties? You're going to write that out in a complete sentence or three. Purpose, to identify if the samples are metal, non-metal, or metalloid. Procedures. First, conductivity. So this is our conductivity meter. See that? First thing you want to do, make sure it starts in the off position, and then turn that little knob on. Here, I'll come around and show you up close. There it is. See it? Okay, go from off to on. Okay, you want to turn it on, and then you definitely want to touch it to something that you know is metal. So let's try that. See if it works. Oh, hey, look at that. Worked. You get a feel for how long it takes to light up, and that tells you if it's conductive or not. So, procedure for conductivity, you're going to see if each sample is conductive. So I don't want to give it away, okay? So you're going to take a piece of a sample without ruining it and test it. We have A, B, C, D, E, F, G lined up. Okay, you need to stay neat with this lab too, because that's all I got of these things, so we can't be wasting them. So you're going to use the conductivity meter in contact with the sample to see if it lights up. Again, when you're done, you got to make sure you turn it off. Let's not waste these batteries. These are pretty accurate, but they're not the most durable things in the world. Malleability. Can I pound it flat? You're going to use a hammer. You're going to use a hammer gently. This is not a weapon. This is a lab tool. I also don't want the table broken either, so let's not use it any harder than that. Can we do that? We're going to see if the thing bends. Okay, so if it bends at all, it is malleable. Some might squish a little, you'll feel them soft. That might be, we can call that malleable. It moves with this, right? Luster. Luster is it shiny? So for that, we have sandpaper if we need. If you see that something is obviously not shiny, then it's dull. If you see something that you think is a metal and it looks kind of dull, that's when we'll give it a little bit of sandpaper to see if we can get the oxide layer off. Okay, so we'll lightly sand procedure. We'll lightly sand samples that need it. That look to be metals, we'll prove to see if they have luster or not. Okay, and then that's it. So on the second page, there's some questions. We're going to put a bunch of yeses and nos for the conductivity for the different samples, okay? Now we're going to describe which ones they are. Remember, a metal will have all three. A non-metal will have all nos for all three, not yeses. And a metalloid is going to have a mix, so it needs at least one non-metal or only one metal for it to be a metalloid. It's going to be a mixture of them. Okay, and explain your idea. I've just kind of explain your reasoning using your data for each of the classifications in question 14. Okay, the 14 is a typo, so let's not do that. Let's talk about 6. We just discussed why we did what, okay? So then restate the purpose of our lab. We just went over the purpose. Claims, each sample is bang to bang to bang, metal, non-metal, or metalloid. What test results are you looking for to support your claims? I concluded the conductivity data I was looking for conductivity. I was looking for how would you know it was conductive? And then your interpretation. I know that samples, I'm not going to give any letters away, were metal and because why. So it's a lot of just choosing why things are metal and non-metal. So this should be a quick and easy lab. There's some obviously metals and some obviously non-metals. So I want you to be careful with your data with that. The ones that there are some tricky that look like metals, but they're going to end up being metalloids because they're missing one of these. Okay. So if they shatter, can't be a metal. If it doesn't conduct, can't be a metal. Remember, it's got to have all three. So that's really it. I want you to be safe, and I want you to not use up everything that's here. Especially if you can get something that's a small chunk. Let's try a small chunk, because if it shatters and we prove it's a non-metal, or at least has a non-metal character, you're probably not gonna be able to use those pieces anymore. So it's gonna be garbage at that point. We'll put that right in the garbage. So let's not use the biggest chunks possible. Let's try to conserve so there's enough here for everybody to do the lab, and that's it. And I just posted a video for how to make a self castle. So you're gonna have self castle and lab, and we test out next week.